All right, so we're looking at the Pythagorean Theorem, and this is something that comes from and is attributed to the man Pythagoras, but may not necessarily have been him. He was just the leader of a cult. The Pythagoreans were a cult from ancient Greece that practiced mathematics and studied mathematical concepts. Were a little crazy. At times, they wouldn't eat beans because they made you fart, and farting was really, really bad. You should not fart, they believed. And apparently, Pythagoras died while running through a field of beans. Poor guy. So, Pythagorean Theorem, cult mathematics. We're going to look at how this works. This is a very useful formula when working with right-angled triangles. You'll use this through most of your high school career. So some definitions. Legs. When we use the term legs, we're referring to a right-angled triangle. They're the short two sides that form the right angle. So in this triangle here, these two shorter sides are the legs. They form the right angle. The hypotenuse is the longest side of the triangle, always will be the longest side of the triangle, and is opposite the right angle. So it's the side that does not touch that right angle. That's the opposite side here. Now, what's the Pythagorean Theorem? Why is it the way it is? Well, this is the actual representation of the Pythagorean Theorem. The Pythagorean Theorem says if you draw a square off the side of this, off of one of the shorter legs, and the other shorter leg, and you take all those little squares and add them up, you will get the same number of squares as is on the large leg. So if we label this side A, and this side B, and this side, I'm going to call it H for hypotenuse, A squared is 9, B squared is 16, so H squared should be 25. And if we add that up, there's 9, there's 4, 8, 12, 16, and then 5. So 16 and 9 is 25. 5, 10, 15, 20, 25. So this is the actual visual representation of the Pythagorean Theorem. It's the squares. The actual. So when we say square again, we're talking about drawing a square. What's the area on that side? So the Pythagorean states that the sum of the squares on the shorter legs is equal to the square on the longer hypotenuse. The formula is a squared plus b squared equals h squared. You will most likely not see that anywhere else except when I write it, because most people will use a squared plus b squared equals c squared, calling the hypotenuse c. I find that confusing because then when we change up the missing side, some people get confused and use c in the wrong spot. H is the hypotenuse, so let's use it there. A squared plus b squared plus h squared. Best way to write that formula out. Moving on. Let's actually use it to find some missing sides. The general steps of finding a side with the Pythagorean Theorem are as follows. You write out the formula. Fill in that formula with the values you know. Square the two values you know. Add or subtract as required, and take the square root. And so you're going to have to add or subtract depending on what you're finding. In the case of A, we're finding the hypotenuse. It's the side opposite the right angle. So we write out our formula. A squared plus b squared equals h squared. Then we'll fill that in. What's A, what's B? Doesn't matter. I'm just going to go 3 squared plus 4 squared equals h squared. Now I'm going to square the two values I know. 3 squared is 9. 4 squared is 16. H squared stays over there. 9 plus 16, I can do that. That's 25. Equals h squared. So h squared is 25. How do I get from h squared? I don't want h squared, I want h. I want the side length h. Well, to do that, I have to take the square root. So I got to take the square root of h squared. Because each side of an equation, these things are equal to each other, I have to do an equal thing on the other side. So I need to take the square root of 25. If I take square root of 25, that's going to give me a 5. And there is my missing value. This side length is 5. 3, 4, 5, very important triangle to know. If you talk to old construction workers who may not have even graduated high school, let alone take it. Your grandpa might not have taken high school, but if he was a construction worker, he probably knows that 3, 4, 5 is the way to find a right angle when you're doing measurements. It's a very useful thing. You can measure 3 feet up one side, 4 feet down across the other. And if there is a 5-foot spacing in between the endpoints, then you know you got a right angle there. Otherwise, you have to move these around until this length is 5. Many construction workers would use this on job sites because it makes easy straight lines. Okay, the next one here, we got a 6-inch and a 10-inch side. However, we got an issue. That's the hypotenuse. So let's try this out. This is going to be a little bit different than the last one. A squared plus b squared equals h squared. Well, that's h. That's the hypotenuse. So I'm going to fill in 6 for a, 6 squared. I don't know b squared, and I know h squared is 10 squared. Well, let's square the numbers. 36 plus b squared equals 100. So now it's a lot different than the last one. The last one, both the numbers were on this side. We just added them up. What do we do here? Well, I got to get this b by itself. I got to get rid of this 36 from here. They're being added together. I'm adding a 36 onto this side. So if I subtracted 36 from this side, it would get rid of it. And because these equations are equal, on either side, it has to be equal. Whatever I do to one, I got to do an equivalent thing to the other. I'm going to take away 36 from the other side. So these two 36s will essentially cancel out. I'm going to be left with b squared. They equal 0, but we don't have to put plus 0 down. And then we have 100 minus 36. 100 minus 36 is 64. Now I'm back to this situation. And these last 3 steps, I can do that. Take the square root of b squared. Take the square root of 64. I get b equals 8. And I should be putting my units in. That was feet up there. This is inches down here. And there we have it, the 2 ways to solve the Pythagorean theorem. You're going to be adding them together if you're finding the hypotenuse. You're going to be doing some subtraction if you're finding one of the legs.